So while we're dealing with the valence bond theory, it explains while electron is living in electronic cloud or in an orbit, it shows wave-like characteristics, not particle-like characteristics. When an electron shows wave-like characteristics, this concept is explained like wave mechanical model. These are the elliptical waves produced by an electron while electron is residing in an orbit or electronic cloud. Generally, a valence bond theory explains the three characteristics: bond length, bond energy, and the shape of covalent compounds. Upon dealing covalent bond, when two atoms come close with one another, their half-filled orbitals overlap to each other. This overlapping of orbitals give rise to the covalent bond. During overlapping, orbitals retain their identity. Their identity will not change. They will remain in same identity while they were living in the atomic state. Overlapping means two or half-filled orbitals come close to each other and they will share some part of their orbitals in free space. It is named as overlapping. Right now I would like to explain the postulates of valence bond theory. When two atoms come close to each other, they give rise or generate bonds, particularly covalent bond. At that time, the orbitals, half-filled orbitals of two atoms come close to each other and overlap to each other. While two orbitals overlap to each other, they will retain two electrons. Both electrons shall show opposite spin. One electron would be revolving clockwise and second one could be exhibiting the anti-clockwise movement. Must remember the postulate number 3. The number of bonds formed between two atoms in a compound should be equal to the number of half-filled of the orbitals. If half-filled orbitals are 1 in one atom, then the covalent bond would be 1 and they will increase accordingly. When two orbitals overlap, means one orbital belongs to one atom and second belongs to other atom, the single covalent bond will come into existence and accordingly they could increase. Overlapping happens between two orbitals. They should reside on the same symmetry. Must remember the bond axis. Let's say two 1s orbitals of two atoms and the plus sign in the middle are showing the nuclei of these two atoms. The line, an imaginary line which passes through the nuclei of two atoms is known as bond axis. The last postulate: while atoms overlap each other, during overlapping, they release energy. If the region of overlap part would be smaller, the amount of released energy will be less. If they would overlap more part, overlapping will be the more area, shared part would be the more area. Energy which would be released between these two, that overlapping would be in higher quantity.